Now we look into the basic concept of the antenna configuration. So any antenna is basically consisting of the smallest element, which is known as an antenna element. Now this particular antenna element, when converted or combined together, it will make a subarray out of it. So any array of these subarrays will make basically a complete antenna configuration or the antenna array. So here, if you see, we have 4 rows and 1 column. The first one is always the row, second one is the column. So we can see that this is one subarray and there are different array of these subarrays, which is 2 row and 8 columns. When we club them together, we'll get an antenna array of 2 cross 2 into 8. So it'll be 32 different radio chains that are available here in this particular scenario, and that's how this configuration we call it as a 32 transmitter. And if we have a similar kind of setup at the receiver end, we call it as a 32T 32R. So this is how the active antenna configurations is basically defined. So it is also known as an array of subarray, and this layout is basically, as we have seen, it is defined on the basis of the subarray size, and it is defined by the number of subarrays further, and how it is being stacked. Is it stacked vertically or horizontally? We'll look into the next slide how these different antenna configurations can help to achieve a different kind of coverage in a different circumstances and scenarios. So if you see, the antenna selection can be done. I've taken the snippets from one of the book, which is written by some of the employees from Ericsson. So if we look into the different kind of allocation of resources in case of sub arrays or the antenna arrays, if we are using 16T 16R, in that case the beam which you see in this case is basically it's traveling far, but it is not very wide. So, and on the other side, if we look into the 64T 64R, what is happening, we are getting a wider beam, but it's not going too far. So what does it signify? It signifies that wherever we have a very dense urban area with the high altitude or high skyscrapers, we can in that case deploy 64T 64R. But if we have to cover a semi-urban or urban area and where we don't have a high-rise buildings, probably in that case we'll go for 16T 16R. That is a better option and a better bet to deploy such kind of antenna arrays in these circumstances. So these different options available for deploying depending upon the clutter type, depending upon the requirement, coverage area we want. All these different techniques in the active antenna system will help to achieve efficiency in 5G radio access network in a big way.